In these problems, we need to take some situations that are described in English, translate them into algebraic equations, and then solve them. So a lot of work here. Let's look at this first one. It says Brenda and Frank thought of the same number. They multiplied the number by 3, then decreased the product by 12 for a final result of 54. What number were they thinking of? So, well, let's take this a piece at a time. First of all, when in a problem like this, when it says a number or the number, that's your variable. So we're going to call that x. And we're going to do to x the things they say they did to it here. They multiplied x by 3. So let's multiply x by 3. We can do that by just writing a 3 out here. This is 3 times x. Then decreased the product by 12. When they say the product, they just mean the result of this multiplication. So the product is this 3x. So we're going to decrease 3x by 12. That is just minus 12. We're decreasing it by 12. And then it says for a final result of 54. What that means is this, multiplying it by 3 and then subtracting 12, ends up equaling 54. So that is our equation. To solve this, not quite as difficult. We're going to add 12 to both sides to get rid of this negative 12 and get the x term alone. So this should be 66, and we just are left with a 3x over here. And then finally we need to divide by 3 to get the x totally alone. And 66 divided by 3 is 22. So apparently they were thinking of the number 22. All right, let's try another one. This one says, find a number such that 19 more than 5 times the sum of the number and 6 is negative 156. Wow, that is a mouthful. The way I like to approach a problem like this is to look for the word is. In the first problem, it said for a final result of. That's a little bit unusual. More likely, you're going to see the word is, and that's almost always the equal sign. And we've got is negative 156, so I'm just going to write that much. So we've actually got half of the equation here. We've got the equal sign and what's on the right of the equal sign. What's on the left of the equal sign is a little more complicated. 19 more than 5 times the sum of the number and 6. Well, let's remind ourselves that the number is usually our variable. So we're going to call that x. And then we've got this 19 more. We've got 5 times. Often it's best to do this backwards, start it near the end of the sentence. We have the sum of the number and 6. That should be easy enough to do. Sum is addition. The sum of the number and 6 is just going to be x plus 6. Now if we back up one step, it says 5 times the sum of the number and 6. So 5 times of this whole chunk, so we can put parentheses around that and multiply by 5. And then if we back up one more step, 19 more than all of that. Well, 19 more than this is just this plus 19. So this is what's going to go on the left-hand side of the equation. We're going to have 5 times x plus 6 plus 19. So that is 19 more than 5 times the sum of a number and 6 is negative 156. Now, to solve here, we can subtract 19, get rid of that. So that should be negative 175. And then over here we've got, well, let's distribute the 5. 5x, 5 times x is 5x, 5 times 6 is 30. So we'll have to subtract 30 from both sides. We're going to get 5x equals 205. And then we've got to divide both sides by 5. And you're going to get x equals 41. Whew. If you get to this point and you're concerned about whether the answer is right or not, you can try taking this and plugging it back in. 19 more than 5 times the sum of the number and 6. So take this, add 6 to it, multiply it by 5, add 19. Oops, this should be negative. I forgot the negative sign. Add 19, and you should get negative 156. All right, let's try just one more of these. All right. So this one says, find the number such that if 7 times the number is increased by negative 30, the result is thrice the opposite of the number. Wow, even more complicated than the last one. First thing you should do is look for the is. And that's right here. In this case, it says the result is. That is our equal sign. And let's try to figure out what's on the left and what's on the right of the equal sign. I'm going to start on the right just because it looks easier. Thrice the opposite of the number. So thrice means 3 times. The opposite of a number is the negative of it. And of course, the number is just x. So the number is x. The opposite of a number is negative x. Thrice the opposite of the number is negative 3x. So that's what we're going to have on the right-hand side of the equation. So let's start writing this out here. So we got negative 3x. That is thrice the opposite of the number. Let's look on the left here. It says 7 times the number is increased by negative 30. Well, the number is our variable, so that's x. 7 times the number would be 7x. And then it says is increased by negative 30. So you could say plus a negative 30 or just minus 30. It's kind of weird to use the word increase there, but that's okay. So we have 7x minus 30. That's 7 times the number increased by negative 30. The result is thrice or 3 times the opposite of the number. So we've got an equation. Now we just need to solve it. In this one, we've got x's on both sides of the equation. I think I'm going to add 3x to get rid of this negative 3x. So on this side, 7x plus 3x is 10x. And we have our minus 30. And over here, negative 3x plus 3x, we get 0 there. We get nothing. Well, that's okay. We can just write a 0 there. And then we want to get rid of this number that's hanging out with the x term. So I'm going to add 30 to both sides. When we do that over here, that adds up to 0. We just get 10x equals 30. And finally, we divide by 10, and we get x equals 3. All right, that was some really tough work with translating word problems into algebraic equations.